Hey guys, welcome to our discussion on experiment 3. So experiment 3 is a titration experiment. And what happens typically when we're in the lab is we do 2 titrations, one of which is HCl and NaOH, exactly as you did in 110, the previous one. And then we're going to do NH3 with HCl, so weak base, strong acid. You're going to be asked a number of different things, one of which is to provide the data tables for this. So you need to make sure that your data tables are in there. Now, one of the questions that I get is what kind of data is going to go in there? Is it the stuff from Alex? And the answer is no. The data from Alex is not what you put in your lab manual. What you need to put in your lab manual will come from D2L. And so we're in D2L for your shell under content and exam 1 and titration. You'll see acid-base titration in experiment 3. And in here, you will see Chem 111 experiment 3 data. So this document contains all the data that you're expected to have for that. Notice that it says what's the indicator, that's phenolphthalein for this one. The color change happened at 25.7 milliliters. The second one, second experiment, the indicator was methyl red, and the color change happened at 20.3 milliliters. So all of that data, all of those lines should be in there. It is perfectly fine if you want to make this a little bit smaller and put that in your lab notebook. That's okay. Just make sure that you've signed across it so it's obvious if it's taken out. That's not a big deal. All right, but that is the data that should be in there. As far as other things that are going to be talked about, you're expected to draw a titration curve for each of these. You've been given a sample titration curve. This is a titration curve template. You just want to put that data in here and have it do the drawing for this one. You'll need to do one for this second experiment as well. So I don't care how you do that. I don't care if you copy this, make another one, or if you just print one out and then or save it file, save as Adobe PDF, and say convert to PDF. And then you give me both of them. If it were me, just if it were me, you can make a duplicate. So if you right click on the sheet, you can say move or copy. You can say create a copy, and it'll put it in there. It will be a copy. And then I would label one of these as HCl NaOH, and one of these as NH3 HCl. And that way I would know which one was which. And that way you'll have a sample for both of them. You'll be able to do both of them. And you'll have those graphs that you can work with. Now you're going to need those graphs. The graphs are going to be absolutely necessary for you because what you're expected to do with those graphs is this. So this is from the lab manual, and I cannot, oh, maybe I can. Yes. So they call it the box method. And so they want you to draw lines across where it's flat here. So extend that flat line from the bottom and extend the flat line from the top part, and then draw a rectangular box there where the center is at the equivalence point. And this point right here, where you're halfway between the beginning and your equivalence point, your pH equals your pKa there. Okay, it does. Why does it do that? This is your equivalence point pH. So you want to know where that point is. And if you're looking at the graph here, if you're following along this and you know that it happened at, I think one of the, well, so when you put your data in here, if it happens at like 20 milliliters, you can follow along and see what that point reads. So if it says 24.53, see what the pH was at 20.53, and you should be okay with that. Okay, but this graph, and again, I don't know how to draw those lines in Excel. I have no idea how to do that analysis in Excel. So I only know how to print this out and do that analysis for it. Okay. I've had people do this on graph paper. I don't really care how you do it. I just want you to do it. It's an experience that you should have. Okay. So there's that part of it. So there's where your data is. You are expected to do that. You need to indicate for each of your titrations, whether it's strong acid, strong base, weak acid, strong or weak acid, strong base, what kind of titration are you looking at? And again, it says that pH equals pKa. You need to explain that. There is a reason that that is true, but you need to explain it. Make sure that you've got all of your data in your lab notebook. Again, your objective is on page 23. The reaction for the first titration is not shown, but titration 2 is on page 24. I do want you to include the reaction for the first titration. It's NaOH plus HCl. I think you can manage that one. As far as the graphical determination, I would put the data into Excel and print out the graphs and do the drawings on them. I'm not sure how Excel can do that. If you can figure it out, please tell me. I would love to know, but I don't know how to do that. You should have an endpoint and an equivalence point determined from your graphs. Calculate the error in those using the percent error calculation. So based on the graph that you have in Excel, you should be able to find that equivalence point, and you'll see that that's different than the endpoint that was recorded in the data. So when you're in this data, did I close the data? Oh, I must have closed it. Darn it. No, where did I put it? So when you're in the data for the lab, let's back up. What you'll see is that it says the color change. That's your end point, not your equivalence point. So that's the end point. So you want to measure the percent error between those two. And the way that we do that calculation for the percent error is to do our actual, so it's actual minus theoretical over theoretical times 100. Your actual here would be the end point. Your theoretical is your equivalence point. And then, of course, we're going to multiply by 100. And the reason that I say that the theoretical is the equivalence point, because we want to know how much of an error there is in relation to that equivalence point. So that's what you should do. And there should be one of those for each of these titrations. Make sure that you record which indicator was used, and it does say for both of them. So you should see that percent error calculation. You'll need to set up an ICE table to determine the KB from your data. Now, all I'm going to say at this point is that you need to do that. That is something that you're going to need to be able to do. And that when you're doing the NH3 titration, you'll have to have the OH minus concentration put in that table, not the H3O plus, even though that's something you're going to be able to measure. So you won't be able to directly measure the OH, but you will be able to directly measure the H. When you talk about the error discussion, there are a couple of things. So you're supposed to compare the two KBs and see if they're the same for the two methods of determination, because there are two ways they're going to ask you to calculate KB. Talk about their differences. Talk about whether or not there should be any differences. Your error discussion should be as specific as it can be, all right? Things that typically go wrong in the lab is that we overshoot the titration. So instead of just seeing that very faint beginning color change, we go right past it. So that may be something that you see in the data that you have. Other things that typically are problematic, or that we're not as careful using the burette as we might need to be. So instead of getting a very small amount added, we added a little more than we should have. That does happen. There is a very unique way that titrations have to be done physically to make them work, and it's an experience to learn how to do them appropriately. So that's something that you guys are missing, and it's kind of sad. I mean, I understand that you may not actually do any titrations, but understanding how difficult it can be to work with the lab equipment to get exactly what you need is part of what the lab is about. And that is not something that you guys get to see. It all looks very easy, and none of it is. So, what else? And explain why the 2 indicators were chosen. So there is an indicator color chart that exists in the laboratory. For you guys in the online class, you can look at the 2 indicators and see where they do their color change. That's based on their pKa or pKb. So go look at that to see where we're talking about and why we would have chosen those particular ones. Now remember, we're probably going to be choosing that based on the fact that endpoint is going to be past the equivalence point that we're looking at for the titration in question. Okay, so that's everything that I want to talk about for that. In terms of the post lab, for number 1, it wants you to explain the calculation using stoichiometry. Okay, for 2, explain where the equivalence point will be for a weak acid strong base titration. Are we at 7? Are we below 7? Are we above 7, and why? For 3, write the dissociation reaction of HA and then the Ka expression, so that's A and B. For C, you'll need an ice table to show the calculations of Ka using the pH. And we have done that. We have done those calculations. So you should be able to do that using an ice table. For D, you want to calculate or compare the values of Ka for HA and Kb for the base. Which is the bigger number? Okay. How do you calculate the Kb, which is the bigger number, and therefore less important in determining the pH is above and below 7? Okay. And then for E, it's a stoichiometry problem. Okay, now that's all I'm going to say about it right now. We will have a specific video about what you need to do for the laboratory. So there is that. Now there is an Alex for this lab. I will tell you that you are not alone in doing the Alex. Everyone does the Alex for this one, and that's because it can be extremely problematic to get a good experience in the lab with doing titrations. So we want people to see what that should look like when somebody, quote unquote, knows what they're doing. So that's the simulation that you get to look at. I think that's everything I have to say about the lab at this point. I will get that video for the lab recorded shortly. So I think you guys will be fine. If you have any questions, comments, problems, concerns, anything like that, please let me know. The next lecture that we're going to be doing, 5, the precipitation lecture, is actually scheduled for next week. I'm planning to record those this weekend so that they're up so that you can see them. Remember that our first test is going to cover lectures 1 through 6, but we will have lectured on more than that by the time you take the test. Okay, but that's the material that's covered on that first test. So all of the Alex for that is due before the test. That way you have it all practiced. But that is the material that will be covered for that first test, is everything in lectures 1 through 6. Okay, so we're getting pretty close. All right, I'm going to stop now. I will talk to you guys very soon, and hopefully you have everything you need. And if you don't, let me know. I'll talk to you later. Bye.